All right, good day, everyone, and welcome to physics class. The topic we want to discuss is fundamental and derived quantity. Don't forget, my name is John Ogike, and we are going to have a discussion on what fundamental and derived quantities are. And before we do that, we want to start with the definition. So, what are fundamental quantities? Just as the name implies, fundamental quantities are those basic quantities that that are independent and cannot be derived from other quantities. Fundamental quantities are basic quantities that are independent and cannot be derived from other quantities. So can we say that one to go? Fundamental quantities are basic quantities that are independent and cannot be derived from other quantities. What that simply means is that they can stand on their own. You can't get them from any other quantities. Do you understand? Now, there are three most important fundamental quantities in physics. What are these three important basic quantities in physics? Number one is length. Length. Number two is mass. And number three is time. Length, mass, and time. These are the three most important quantities, that is fundamental quantities in physics. Now, let's look at the fundamental units. Now, what are fundamental units? The fundamental units are the units of these fundamental quantities. That is, these fundamental quantities, they have certain measurements, and these measurements are their units. Now, for example, length. Length is also a distance, so it is measured in meters. Length is measured in what? In meters. That is the standard unit of length. Then mass. Mass is measured in kilograms. Mass is measured in kilograms. That is kg. And time is measured in seconds. Time is measured in seconds, which is s. So to go a little bit further than this, let's look at, apart from this now, let's look at some other fundamental quantities and their units. Those quantities that cannot be derived, that can stand on their own, apart from the one we have just mentioned or listed, the length, the time, and the mass. There are other fundamental quantities. Example, we have temperature. We have the temperature. Temperature is measured in Kelvin. Temperature is measured in Kelvin and K. We also have electric currents. Electric currents. Electric current is presented with I and it is measured in ampere. Electric current is measured in ampere. We also have resistance. Resistance can use R to denote resistance and is measured in ohms. So resistance is measured in ohms. So these are some of the fundamental quantities and their units. Now, having done this, we want to quickly move to derived quantities. Derived quantities. I hope now you understand what fundamental quantities are and the examples of fundamental quantities. Now you understand what fundamental units are and examples of fundamental units. Let's quickly move over to derived quantities. Again, let's start with definition. What are derived quantities? Just as the name implied, derived quantities are got from the combination of fundamental quantities, or we can say derived quantities are got from other quantities, and of course they are got from the combination of fundamental quantities. So derived quantities are got or dependent on fundamental quantities. Fundamental quantities. So what we mean is that derived quantities, they are got from other quantities. And derived units, of course, they are the units of derived quantities. And as we go into it, you are going to see that it is the combination of the units of fundamental quantities. Now, let's quickly look at examples of derived quantities, their dimension, and their units. Examples of derived quantities. Now, we have force. Okay, let's quickly put in tabular forms for easy or for better understanding. Let's have the quantity, then we have their dimension, and the units. Now the first one, let's look at force. Force. Force is an example of derived quantities. And force is mass times acceleration. Force is what? Mass times acceleration. These dimensions are also like formula. Do you understand? We can use this dimension as a formula to solve, to get some of these fundamental derived quantities. Do you understand? And mass is measured in Newton. Force is measured in Newton. Force is measured in Newton. Then we have acceleration itself. We have acceleration. Acceleration is change in displacement or velocity over time. So we can simply say acceleration is what? Displacement over time. And it is displacement is just like a distance, which is okay. Acceleration is change in velocity over time. Sorry for that mistake. Change in velocity over time, and velocity is measured in meter per second. So unit of acceleration is meter per second square. Meter per second square. Then we have density. Density is mass over volume. Density is what? Mass over volume. And density, mass is measured in kilogram and volume is measured in meter cube. So the unit of density is kilogram per meter cube. So we are also, let's quickly look at one or two more of derived quantities. Now we have impulse. Impulse is force times time. Impulse is what? Force times time. And remember I told you unit of force is Newton. So we are going to have Newton second. That's the unit of impulse. And then we have pressure. Pressure, the dimension for pressure is force over area. Force over area. So the unit of pressure can be Newton per meter square, or we can say bar or Pascal. Pascal is a standard unit of pressure. Pressure can be measured in Pascal. That is PA, and it can also be measured in bar. Do you understand? So these are some of the examples of derived quantities and their units. So we are going to end the class here for today. Don't forget, my name is John Ogike, and we are going to meet in our next class. I hope you all understand. Thank you very much. See you in the next class.